Hello, my name is Derek Fields. My group and I would like to introduce you to a fairly new technology, piezoelectric floor tiles. Helping me to do this will be my fellow classmates from Purdue University, Holly Dunn, Dusty Dexter, Bud Smart, Christine Lucas, and Jared Kelly. In determining a project to explore for this class, we studied many angles of helping our environment, benefiting our university, as well as trying to educate the local community. We studied both new and old technologies in an attempt to reinvent an idea in which Purdue could be proud. After deciding upon the piezoelectric technology, we had to determine the specific avenue of the technology with which to use. While piezoelectric technology itself wasn't something new, placing the technology in a floor tile was something new and exciting. Next was the challenge of coming up with an idea of implementation. What better place than Ross-Ade Stadium, a place where foot traffic would be most congested. The trials that came next for our group was a learning experience for us all, and we believe we came out better in the end as a team. By choosing piezoelectric floor tiling, we have the confidence that we can aid our environment, support the university, and help our community with many more benefits still to come. We believe we can challenge our fellow Boilermakers to create a charge unrivaled by all others. Go Purdue!
Thanks, Derek. My name is Bud. And now I bet you're wondering what piezoelectricity is and what it does. The answer to this question can be extremely technical, but I'm not going to bore you with all of that today. Basically, piezoelectricity is the transfer of energy, and in this case, we are talking about a renewable energy that costs nothing to produce. This technology gives us the ability to reproduce electricity without harming the environment. I know this is going to be hard to believe, but piezoelectricity was first conceived in the late 1800s. Now, this technology we are going to talk about today has only come about in the last 25 years or so. So by now you're asking yourself, what is piezoelectricity? Piezoelectricity means electricity resulting from pressure. There are certain elements or crystals that when you apply pressure, they produce a small electrical charge. This technology is not new, but the applications we will be talking about later in the presentation are fairly new. Please take a look at the diagram as I describe how the electricity is generated. For this application, we are talking about using the movement of people to generate a renewable energy. This diagram gives us a visual representation of how this process works. What we call this is dance floor power. First, we take a nightclub and we fit it with what we call a bouncing floor. This floor is made up of springs and a series of power generating blocks. The blocks are made of crystals which produce a small electrical current when squashed. This is the piezoelectricity. As dancers move up and down, the blocks are squeezed. Current is then fed into nearby batteries. The batteries are constantly recharged by the movement of the floor and used to power the parts of the nightclub. Now, this is just a simple explanation of the technology, and with this type of technology we are envisioning endless possibilities for other applications where there is heavy foot traffic. And with that, I want to turn it over to Christine.
As stated earlier, piezoelectric technologies are not something new. However, as time has progressed, people are beginning to better current uses and create new ones in order to put it to use in more places. One of the newest uses is piezoelectric tiles, which harvest energy from footsteps. What better place to use this type of technology than busy places such as city sidewalks, the mall, train stations, or concert venues? Today, we see piezoelectric tiles being used in dance clubs. According to research, the key is the crowd. The energy absorbed by the tile in one footstep can only provide enough electrical current to light two 60-watt bulbs for 1 second. Therefore, the greater number of people moving across a piezoelectric floor, the greater amount of power produced. As a result, this power is then transferred to power the LED lights. The idea behind the piezoelectric tile is to harvest energy and convert it to multiple uses, not just lights. Think of all the energy we produce by burning fossil fuels and other resources. Piezoelectric tiles will help reduce our carbon footprint.
Every time we take a step, we leave energy behind. What if we could capture this energy as a clean source of electricity? Dutch architects Dol are developing the technology to capture the energy of dancers like these, then using it to power the club's music and lights. Certain materials produce electricity when squeezed. This is known as the PIEZO effect. So a dance floor can become one big generator, turning every movement into new power. In fact, any vibrations we make can generate electricity. Even the rattle of the tram taking you home at the end of the night.
Some piezoelectric inventions are already successfully being used. A dance club in the Netherlands called Sustainable Dance Club is partially powered by piezoelectric pads underneath the dance floor.
This is our budget outlook for the implementation of the piezoelectric tiles into Rossade Stadium. You can tell from this that we have allotted a generous $38 per hour for labor, and in best circumstances this should be significantly lower. The primary material cost will be from the piezoelectric generator and from the tiles themselves. Overall, we think the costs to implement this project are minimal, considering the potential from energy generation for the system. The project will eventually be paying for itself. We are also expecting to potentially receive government grant funding for this project. That is why we have allotted paying a grant writer into the budget. We predict that the project should take a total of 18 months to complete from start to finish, with the construction portion of the project only taking approximately 1 week. Overall, I feel that the numbers show the amazing potential for benefit from the implementation of this project. There is no doubt that the funds invested into this project will be put to good use.
Future sidewalks might be covered with smart panels that capture piezo electricity, power generated from applied mechanical pressure.
As this technology develops, we will be able to place this into every single airport terminal, every railway station, every large city intersection, on every sidewalk.
Society is constantly improving how to make our world more environmentally friendly and reduce our carbon footprint. Our group's vision is to apply piezoelectric technology to our local community. This will create a sense of connectedness to our world as we improve our environment. Our proposed plan is to install piezoelectric tiles in the stadium at Rossade. By doing this, as Purdue fans, alumni, students, and visitors cheer on our beloved Boilermakers, they will be generating energy. This energy will be stored and can then be used to help power the lights of the stadium. Although the enthusiastic cheers, clapping, and stomping may help lead our team to victory, it is also an untapped fountain of energy. To help create knowledge and excitement about the energy savings, we can challenge the members in the stands of the stadium to see how much energy they can generate. This will create a healthy competition to support our team, community, and the environment. We will be empowering our community through morale and action as we collect unused energy with piezoelectric technology.
My name is Dusty, and my team has presented to you the uses of piezoelectricity and the way in which it is generated and captured. One of the many benefits of this form of electricity is that it is 100% renewable. We will never run out of this type of energy. This method of capture is a fairly new concept, but the type of energy has been around since the beginning of time. All it takes is a vibration and a method of capture and storage for future use. With the process of laying the tiles, connecting them to a capture generator, and converting the vibrations into a completely renewable source of energy, we will be reducing our impact on the environment. It is our intention to spread the word about this technology so we may create a cleaner, safer environment for both ourselves and our children. So spread the word. Let's challenge ourselves and each other to implement this energy capture practice wherever it is useful. In the future, we envision tiles lining every subway station and sports arena. With the progression of technology, we see vibrations being captured from thin air and stored, runways lined with flexible tiles, and everyday equipment like treadmills to be designed with piezoelectric tiles to have the capabilities to power themselves.